In this video, we're going to take a look at interior angles in a polygon. Now, we already know from a previous video that the sum of the interior angles in a polygon can be given by the formula n minus 2 times 180, where n is equal to the number of sides that are in the polygon. Let's use that formula to help us find the sum of the interior angles in this problem. So the polygon has 10 sides, find the sum of the interior angles. So I would plug in a 10 in my formula. And then simplifying that gives me 1,440 degrees for the sum of that decagon. Now let's say I told you in addition that this shape was a regular decagon. Regular means that all the sides and all the angles are the same. If that is the case, what is the measure of one interior angle? So then I would take the sum and divide by how many angles there are, because each angle is congruent, thus giving each individual interior angle to be 144 degrees. We can apply this same idea to work backwards. When I'm given the number of each interior angles, or the measure of each interior angle, I can work backwards to figure out how many sides the polygon has if all the angles are the same. In this case, it's a regular polygon, so I know all the angles are the same, so I can go ahead and solve this. So looking at this particular problem here, if I'm given a 60-degree interior angle, I have a couple different methods that I can use to solve this. I can use the fact that I know the sum of the interior angles is given by this formula. And then if I want to find each individual angle, I need to divide it by how many angles there are. In this case, that's n, because I don't know that. And I can set that equal to 60 degrees. Then I can use my cross products property to solve that. 1 times n minus 2 times 180. I don't need to put the 1 times there. And I missed an n. When I do my cross products here, I should get 60n. Now I'm going to go ahead and solve this by first distributing the 180, and then I'm just going to solve here. So I go through all that work to get that n equals 3, that it has, my shape had 3 sides. And I guess if it's a regular polygon and each angle is 60 degrees, that makes sense that it's a triangle, because I know equilateral triangles have 60-degree angles. That's a shape that I'm pretty familiar with. There's another method that I could use to do this, and that would be, if this is my polygon, now I know it's a triangle, so I'll draw a triangle. But even if I didn't, if I knew this interior angle was 60, based on what I know about exterior angles, I would know that this angle would have to be 120 degrees. And that's really helpful because I know the sum of the exterior angles is always equal to 360 degrees. So if each one is 120 degrees, it's a much shorter equation to solve and get 3 sides. I'll do one more for you. If the interior angle is 156, that means n minus 2 times 180 divided by the number of angles has to equal 156 degrees. So again, I'm going to use my cross products property and solve this. And then I'm going to work to solve for n. I'm going to distribute here. Subtract 180 from both sides. And last, divide. And I'm going to get n is equal to 15. So this shape is going to have 15 sides. My other method would be, I don't know what my shape looks like maybe, but I know that this interior angle, I'm just going to roughly sketch this out, this interior angle is 156 degrees. So if I extend that side, I know that my exterior angle plus my interior angle have to equal 180 degrees. So I can figure out that my exterior angle would have to be 24 degrees. And I know the sum of all my exterior angles is 360 degrees no matter what the number of sides is. And then if all the exterior angles are the same, because again, it's regular, I would just divide by 24 and get 15 sides. So that is two different ways that you can use that information about what we know about an interior angle to figure out how many sides a polygon would have.